Hello everyone, welcome back again. So in this tutorial series we will see how to do the setup process. So first thing is you guys have to download Unity. So the version of Unity that I am using is this one. Let it load. So I think it is Unity 2018.4.2 F1. Yeah. So this is the version of Unity that I am using. So you guys have to go to Google and download this version of Unity. That's it. And I already had done a couple of setup for the project. So our project name is reach to exit. So the objective of the game is there will be exit in each level, and to reach the exit the player has to uh, cross hurdles, solve puzzles and defeat enemies. Then only the player can reach to exit. That's the reason I had given this name. So this project is already set up, and let me load that project first. Okay, it's loading. uh, Come on. hmm okay. Okay, it's loaded, I think. So let me go for new scene here. Okay, and this project whatever I have here, I am taking a reference from other project. So this is not the actual project. I already, let me show you the actual project also. Okay, this is the game, this is the project that I am referring. So here in this project I have created around 16 levels of the game, and that's what we are going to do in this project. So I will be referencing this project. It is this game project I am going to reference, but we will be creating all those things from scratch in this existing project. So for any 2D platformer game, the first thing that we need is a platform. So when I say platform, the platform will be a straight platform where the player can traverse. So here I have created a prefab called traversable area underscore collider. So what is this is, so if I drag and drop it here, this is a platform in which a player can walk, means a player can move around, and these are all walls. This yellow is a wall and green is a wall and blue is a ceiling. So let me put a player first. So let's create a 2D game object and give a yin yang symbol. So if this is a platform and if this is a player, using our keyboard or controller we will be able to move our character left or right, so that player can move like this. And if the player collides with the wall, the player has to stop, and the player can jump also in the game. So if while jumping, if the player hits the ceiling, the player will come down. So these are all the functionalities that we will be doing. But in this video I will tell you how to set up this platform, because once this platform is set, we will be able to give interaction to this platform with respect to the player. That is, the player can move on the platform, the player can collide with the platform, we can write all the functionalities. So this is a prefab that I made But how the structure of this prefab, let me explain it to you guys. So first thing is, let me open this prefab, okay, and let me delete this script. I will come to the script later. Now this prefab, if you see, make it center. This is an empty game object where it is placed at 0 0 0, rotation is 0, scaling is 1. So we won't be changing the rotation of this prefab anytime, or we won't be rotating this platform at any instance in the game. So there won't be any uh, rotation affections, like sorry, means rotation won't be affected at any point of time in our game. So it will be just a scale and position. So this is our empty game object that I created at 0 0. So this is the pivot, and under this we have one more game object called collider. So this is placed at 0.5 so it is at the center. So now if I click on the parent, I will be able to yeah, okay, let me, I will be able to move this anywhere. So this will be the pivot, and I will be able to scale it like this. So that's it. So we kept this sprite renderer. So this is for platform. So for the player to know this is a platform, I created the sprite like this, and I kept it at this position, nothing much. And then comes the collider. So for any 2D platform like this, there will be a ground, there will be a walls, and there will be a ceiling. So the game object that I created over here, the red, so this is a game object. This is placed at 0 0 0, and blue, this is also placed at 0 0, yellow, green. So all these game objects are in the same position, okay. And for this I created a edge collider. So edge collider is something like where you can plot the points and you will be able to make the collision out of it. So if I say edit collider, you will be able to see 2 points, the point 1, that is this point 1, and point 2. These 2 points make the collider. So we have created a collider for a ground. Next thing is blue. So if I click on this blue, there is a collider for the bottom. This is for ceiling. And yellow, this is for walls. And for green, if I do this, you can see there is a collider for a left wall. We can simply put box collider 2D like this. It will also work, but it will be very difficult to differentiate between ground, walls, and ceiling. So that's the reason I am splitting the colliders in 4 parts: one for ground, walls, and ceiling. That is 2 walls, 1 ground, and 1 ceiling. So all these colliders are set up here, and in each uh, game object I have created a line renderer game object. So under this ground game object I created this line renderer. So line renderer is nothing like, if you guys want to do some trail effects, or if you guys want to draw a line from A to B, you can use this for special effects or even for editor scripting. In our case, we are going to use this line renderer for visualization point of view in editor, so that when the player, if they drag and drop any of this, okay, let me one second, let me add this script first, collider property, okay, but this will be disabled, okay. So if the player drags and drop this prefab over here, they will be able to visually see the boundaries around this platform. So red indicates ground, this two left and right indicates wall, and the bottom one indicates a ceiling. So if I go here in the line renderer, for the ground I have created a line renderer, and the line renderer width is 0.15, and this line renderer has two positions, start position and end position, and this position will be filled by this script. So this is an editor script that will run only on editor. So currently I will disable this. So if I disable it, nothing will happen for this renderers. So if I do scaling, nothing will happen. Even if I move the game object also, this line renderer, it won't move. That's because the script is disabled. So this script controls this rendering. I will tell you what happens, but it's very easy. So what we do is, under each game object we create line renderer, and we give start and end point. So for this line, this red line, the start point is this and the end point is this. And for blue, that is the ceiling, the down one, we are creating line renderer, one more line renderer, and we are setting its width to 0.15, and we are assigning this blue material. By the by, all this material resides in a material folder here. So for red line renderer, I am assigning the material, and the material is over here in this folder. And for blue, it's also here, yellow is here, green is here, and there is one more material called laser, which we will see in future. Currently we are not going to use this. So for blue, I created one material and I have assigned it. And for yellow, this is for wall, I created a material and assigned it. Same thing for green also, so I assigned the green material also. So in each line renderer I am having the start and end. So for this, if you see, for the left to all, this left section, start point is this, end point is this. And for the yellow section of line renderer, the start point is this, end point is this, and here start end. So this is just a setup that we have done. Okay, nothing fancy stuff that is happening over here. So we create one empty game object at 0 0, and collider, I am creating it and I am assigning white. So our platform is going to be square shape or rectangle shape. So this is currently, it is a square shape. So if you scale it in 5 and 2, then it becomes like a rectangle. Okay, so for to visually view the platform in the game, we created this sprite white, and we will be able to change the platform color. Okay, we are not going to put any texture, we are going to keep this sprite plain. Means we won't be having any designs in this. It's a plain white texture, and we are going to set this if you click on the sprite, it is located at the sprites folder. Okay, and the texture type is set to sprite 2D, and pixel per unit is 100. Okay, so this is setup. And for yin yang also, we have this character, our game character, that also resides under sprite folder, and we set its texture type to sprite 2D. So what we do is, we just assign this white sprite over here, and we will be able to change the color. And under this, we have colliders for ground, ceiling and walls, and for each of them to be visualized, we attached a line renderer, and we had given start and end position. Now we have to draw a line from start and end point. So let's come to this editor script. What is the use of this editor script is, whenever I scale this object like this in x-axis 5, even this line renderer is getting scaled. How it happens? So when I scale it, this game object, this entire things under under this game object, whatever is there, that is also getting scaled. And if you see the endpoint, this also is getting scaled in x-axis. So for each endpoint, if you see, the endpoint differs. since I had done the scaling. So if I do if the parent object is scaled 5 in x-axis and 5 in y-axis, then all these things will be scaled. That is, and the line is getting drawn. And if you see the line renderer, these positions are dynamically getting updated. So we take the start point here and endpoint here, since it is under the child of this parent game object. Whenever you scale the parent, the start point and end point, this is also getting scaled, and we retrieve this information in this code and we draw this line. So let me open this code here. Okay, it's starting up. If you don't have the script, then it won't scale or it won't move. Line render will remain still. So let's switch on this. So this is a simple script. So if you guys see here, this is a class collider property and it's inheriting from mono behavior. So we can attach this script to this game object, and we are saying execute in edit mode. So when you say execute in edit mode, basically this is a edit mode, the game is not running. In this time also this script will be running, and I have introduced four bool variables. This is just a disable red, blue, yellow, green. I will come to that. So okay, before that I will show you how it works in editor. So we have this disable red col, it means disable red collider. So when I say this, when I tick this, there won't be any collider for ground, so this is disabled. Like that I can disable blue, I can disable yellow, I can disable green, so there is no collision. Now it is just a sprite with no colliders. So if I want to enable all of them, just uncheck it so that you can see it. So that's what this bool variable does. Okay, and in here we have four game object: up collider, down collider, left collider, right collider. So this will be extracted in start method. So in start method, what I do is I say transform dot get child of 0 dot find red game object. So I find transform dot find dot child get child of 0, that is I get this child, and in under this I am checking game object name red, that is this is the one, and I am giving that to up collider. Similarly for down also I extract blue and I assign it, and for left is this collider and right is this collider. So this is what we do here. We just find the game object and we assign it here. And next we are checking whether the application is playing. So what this function does is whenever our application is played, whenever you are in play mode, this condition will be executed. So what we do here is, while we are in play mode, we don't want this red line, blue line, and green and yellow, because we don't want to visualize it. This is only for editor purpose, and we don't need this script also, collider property. All these things will be useful only on editor mode. So we don't need line renderer and the script while the game is running, so that will save lots and lots of performance. So what we do is we actually iterate through this collider child count. So in our case for red we have only one child, blue, yellow, everything has only one child. Okay, see, so we are iterating through all this child and we destroy this line renderer. Okay, for up, down, left, right, and at last we say destroy this. When we say destroy this collider property, this script also will be destroyed. So when I run it, you can see the script will be gone in play mode, and when I close this, means when I stop, it will come back again. So in runtime, none of these things will be running, everything will be destroyed. And there is this update method. So in this update method only we do the line renderer calculation. So we check first if it is a Unity editor. It means if currently this is a Unity editor, if the same thing is running on PlayStation 4 or Xbox, then this condition will won't be satisfied and this code won't be compiled. So what they call it as a macro in C++. So this is called conditional compilation. So if it is not Unity editor, this whole source code it won't be even compiled. It will be just taken out completely. So since we are in Unity editor, this condition will be satisfied and we are checking whether the application is not playing. It means are we in edit mode? Yes, currently we are in edit mode. Now we are going and creating a transform parent equal to null, and for this parent what we are doing is we already got this upcall from start method, that is we extracted this red game object and we are saying transform.getChild of 0. So what we are doing is when we say upcall.transform.getChild of 0, so upcall is basically this red game object and we are saying get the child, zeroth child, that is this line renderer, and that will give you this transform. Now what we do is we get the line renderer at this line upcall.transform.getChild of 0. Again this will return the line renderer game object, and we get the okay once again and we get the renderer itself, and you can set the line line renderer position using code like this. When we say set position, we are saying set the 0th position of the line with this value. So what is this? So this parent currently it points to line renderer, so it points to line renderer, and we say line renderer dot transform dot get child of 0 dot position. So for line renderer the first child is start, so we are taking this position and we are assigning it to 0th index, and for position 1, that is the endpoint, we are saying child 1, get child of 1. This will give the endpoint. So when we do this every frame, and when we alter the scale like this line renderer is also getting updated, because your start and end point will be updated dynamically when we scale the game object like this. So when I scale it in x and y, this start and end point, this is also getting updated, and we take this updated value here and we put it at this set position. So like this we do for left collider. Let me tell for one more thing. So here we have this left collider dot transform dot get child. So this left collider is nothing but our green wall, that is the left wall, and we get the first child, that is line renderer, and assign it to the parent. Now for this left collider we have this line renderer component attached, and we can get the line renderer component, set its 0th position index like how we did for up collider. So we get the line renderer dot transform dot get child of 0, that will give the start position, and this will give the end position. So it does for left side, and it does for down collider, that is for sailing, that is blue color, and the last one is for right collider, that is for yellow, this is the right wall. Now we have done all the setup, so now it scales dynamically. And this condition, what we do is if the developer clicks disable red here, update method will be running in editor, and if this condition is true, we actually set upCollider.set active false, else true, like that we do for blue, green and yellow. So I think the code is pretty straightforward, and let me adjust this line. Okay, I hope it's okay. So that's what this editor script is all about. Let it compile. uh, Now let me unlock everything. Now we can see all the colliders. So this script basically does the visualization part in editor. And one more thing, if you see, for all the game object we have line renderer, and its width is set to 0.15. So you can control the line renderer width by like this. You click here and you can type 1. It will be so big, but I don't want that much big, so we keep it 0.15. So same thing for all line renderer over here. I hope it's the same. And we set its position, that is 0th position and first position, using this script, that is collateral property. And if you I think that's it. So one more thing that we have to do here is, under this collateral we have this red, blue, green, yellow. The reason why I have not given the name ground, ceiling, I can give names like this, but you know, when we are working with the script, initially it was like disable ground collider, disable ceiling collider, disable right wall collider, disable left wall collider. But it was very difficult from human perspective, because we are drawing a line for ground red color and ceiling blue color. But when I say here disable ground, sometimes the name and the color, it is very difficult to keep in mind, means people won't remember, okay, red color is for ground. So that's the reason I have given uh, here disable red collider, and even I named this collider name also similar to the color name. So I made it red, and here I am making it to blue. So the color name and the collider name will be same. So if someone wants to disable it, they don't want to remember any of these things. Okay, I want to disable this right side. So what is this color? This is yellow color. So just to disable yellow, it will be gone. Like that, if I want to do for green, I can do this. So I don't want to remember the name. It is just for our understanding, we had given this name so that it will be easy. So when you have multiple instances of this platform, then you will understand what I am talking about, because the confusion will come with multiple objects, not with single object. So when you see the single object, it's easy to track, but when you have hundreds of platform in your game, it is very difficult to understand. On that time, visually when you see things, it will be more clearer. So that's what that's the reason I am giving this names. So now for red game object, now we have to almost platform is set, and for platform we have to set the layers and tags, so that we can use this in our script, so that player can interact with this platform, and player can be collided with walls, and he can move around on the platform. So for that we are going to set up a layer and tag. So for this red, I have set a layer to ground and tag also to ground. And if you don't know how to add a layer, it's like this. Go here and say add layer, and here you can type your blah 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 stuff. But currently I am typing ground. And for blue, this is down one, it's a ceiling. I added this ceiling. And for yellow and green, I made it as wall. I never gave it as a left wall or right wall, because anyway it's just a wall. At this point of time that's not required, so I had given it a unique name. So wall layer is also added. Similarly the tags also is added like this. If you want to add new tag, you can say blah 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 like this and save, but currently this is not needed, so you can remove it. And one more thing is, when you remove the tag, it won't be refreshed. The next time when you open the Unity, this tag whatever you removed, it won't be present here, it will be gone. So now for ground, I set the tag and layer. Tag is ground, layer is ground. The reason why I'm setting tag and layer both the things to ground, those things I will explain you in the future video, but currently keep it like this. When the time comes I will tell you. And for blue also, I am setting ceiling, ceiling, yellow, wall, wall, green, wall, wall. So I think our platform is set now, and we are able to scale our platform. One thing is, our platform won't be scaled in z-axis, or we won't be manipulating the platform z position, and we won't be manipulating the platform rotation. So it's a plain 2D game, so platform scale in z-axis will be 1 always. Not only platform, all the game objects in our scene will have scale in z to 1. We won't be scaling in z axis, and we won't be manipulating anything in z axis, because this is not a 3D game. So we can scale our platform now, and we can see how it works. And I made this as a prefab here, over here. So whenever we want a platform, we can drag and drop it here. So let me create few platform for you guys. This is at 0 0, keep it 5, and here 3, and duplicate one more platform. The next platform will come at 5, because already you scaled to 5, and you keep it 5. Now we have this, and we can duplicate one more platform and keep it like this, keep it like this. And when you run it, see, we are able to see it, but there is no player, there is no interaction, nothing's happening. Those things I will teach you in the next video. So see you guys, bye, take care.